Welcome everyone, Mr. Vidich here. Today we're going to be looking at lesson 1.6, entire radicals and mixed radicals. So you'll remember from last lesson that when we're multiplying radicals, and they're two separate radicals, for example the square root of a times the square root of b, we can combine both of the numbers under one radical sign. So in this case the square root of a times b. And then the same thing when we're dividing. Over here, the square root of a divided by the square root of b can be written as a divided by b, all under one square root sign. Today we're going to look at how to convert entire radicals to mixed radicals. Okay, let's look at example number 1. It says, write the following as a product or quotient of radicals. So the first one says the square root of 24. Well, we can write that. We can split that up. We can split that 24 up into 4 times 6. And because of our radical laws up here, we can now split those up into two separate radicals. So the square root of 4 times the square root of 6. Okay, let's do that for a couple more numbers. So I have the square root of 18 over here. Well, I can rewrite that as the square root of 9 times 2. And then I can split them up into the square root of 9 times the square root of 2. The same thing for when we're dividing. So the square root of 11 divided by 4 over here can be written as two separate radicals of the square root of 11 divided by the square root of 4. Okay, let's move on to number 2 here. So it says use a calculator to approximate the value of each radical to 5 decimal places. So get your calculator out here and let's see what we get here as the answers. Okay, let me move this up a little bit. Okay, so you'll see here that when you punch this in your calculator, the square root of 80 is 8.944, and 2 times the square root of 20 is also 8.944, and 4 times the square root of 5 is also 8.944. So we see a pattern here. So it says here, what do you notice about the answers? Well, they're all the same. Okay, so the answers are the same. So let's look at why these are the same and how we can go back and forth between the three here. But before we jump into that, let's look at some definitions. So the first definition that we have is an entire radical. Well, an entire radical is when the number is under the whole entire number is under the root symbol. For example, here the square root of 80 is all under the square root, and I sometimes call the square root sign or the root sign the house or the roof, I should say. So if I say 80 is under the roof, you'll know what I'm talking about here. Okay, so you can see here that 80, it's all under one roof here, so it's an entire radical, while these ones here are mixed radicals because not everything is under one roof. For example, the 2 here and the 4 here are outside of the radical sign, and therefore because we have some information, some numbers inside here and then some numbers outside, it's a combination, so we call it a mixed radical. So a mixed radical, well, the radical, the whole thing's a radical, but again the radicand is under the square root sign or under the roof, and the stuff on the outside, the number on the outside, is called the coefficient. So the idea here is the key thing here, and we'll put a little star around it, is that wherever possible, entire radicals should be converted to mixed radicals. Okay, let's move on. So we've done this before here, filled out our table, and it's our perfect square table. So we can say that the square root of 1 is an entire radical, while the 1 part is is a mixed radical. This is a little bit weird because all of these numbers, the square root of square root of 4 here, the square root of 9 here, the square root of 16, the square root of 25, and so on. So these, the top part here is all entire radicals. While the bottom part, you can say they're mixed radicals. But really they're just whole numbers. So let's look at a few more examples, and hopefully I'll get the hang of it. Okay. So you can read these steps here, on your own, but I'm just going to go through them while I do an example here. So I'm just going to jump to example number 3, and the question says, convert the following radicals to mixed radicals in the simplest form. So right now what we have here under A, we have everything under one roof, so that's an entire radical, and we want to get it to a mixed radical. Okay, so the first step in doing this is to find the highest perfect square that goes into 50. And again, you'll remember our perfect squares, I'll write them up here, are 1, 4, 9, 16, and try to memorize these because they will make your life a little bit easier. 25, 36, 49, 64, 81, and then 100. So try to memorize at least to 10 here, the 10 numbers. So what's the highest perfect square that will go into 50? Well, if I look at my list above here, I see that 25 is the highest perfect square. So how is that going to help me? Well, what I can do is I can rewrite this radical sign, and what I'm going to do is I'm going to put, instead of putting 50 down, I'm going to put 25 times 2. It's the same thing. 25 times 2 is 50. So I didn't really change the value of my answer. That's really important. You keep everything equal. And now, remembering our radical rules, I can split this up. In other words, I can go the square root of 25 times the square root of 2. According to our laws, we're allowed to do that. So I'm going to do this. And here's why I'm going to do this. Well, the square root of 25, I know, is going to be 5. So the answer here on this one is going to be 5. Now the square root of 2 is already simplified, and I mean I can do it on my calculator and I'll get a decimal, but we're trying to avoid decimals here and stick with whole numbers. So that one the square root of 2 is just going to be the square root of 2. Nothing changes here. So that is your final answer, and this is a mixed, and up here is the entire. So those are the steps of going from a entire radical to a mixed radical. Let's do a few more here so everybody gets the hang of this. Okay. And the square root of 45, again, the first step is ask yourself, what is the highest perfect square that goes into 45? Well, if I look at my list up here, clearly 49 does not go into 45. It's too big. 36 is also too big. 25 is not too big, but it doesn't go into 45. 16 does not go into 45. And if you can't figure out whether any of these is a factor of 45, you can just go on the side here, 45 divided by 16. And if you get a whole number, then 16 is the highest perfect square. However, this is not going to work because we'll get a decimal. However, 9 works. Okay, 45 can be split into 9 times 5. Okay, and again, 9 is the highest perfect square. So then I'm going to split these up into the square root of 9 times the square root of 5. Well, we know what the square root of 9 is. It's just simply 3. And the square root of 5 gives us a decimal, so we're just going to leave it as square root of 5. So your final answer is 3 root 5. Okay, let's look at C. we have the square root of 320. And this one might be a little bit trickier to find the highest perfect square, but if you go through all the numbers, you're eventually going to get to 64. 64 as the highest perfect square. So I can split the 320 into 64 times 5. And that's all under one radical. Okay, that's step number 1. And then I can split them up into the square root of 64 times the root of 5. And then the square root of 64, well, we know it's 8 because we memorized our table. The 5 again just drops down because it's not a perfect square. So there's our final answer here. Now, let's say for some reason you chose a perfect square, but it wasn't the highest one. For example, for this one, 320, 16 also goes into 320. So let me just do it that way, just in case somebody, this happens to you here. So let's say I'll read it up here. The square root of 320. Now this isn't the wrong way, but it's certainly the long way. So let's say you went 16 times, and what is that? So 320 divided by 16 gives me 20. Okay, so 16 and 20. And then I split them up into two separate ones. And then my the square root of 16 is 4, and I just dropped the root 20 here. You're not wrong here, but you're also not entirely correct, because the 20 here can be further split up into another highest perfect square. For example, let me rewrite the 4, because the 4 is already outside the house, and I'm going to split them. So it's 4 times, and then the root 20, I can split it up as 4 times 5. And the 4 is our highest perfect square again. So now I rewrite it as 4 times the square root of 4. I split them up in the square root of 5 here. The 4 that's on the outside, this 4, that one you just keep dropping down, because it's already in the outside. It's already part of the mixed answer here. Now, what's the square root of 4? The square root of 4 is 2, and the square root of 5 is just the square root of 5. Now look what we have on the outside. We have 4 times 2, that gives us 8, and then the square root of 5 just keeps going down, and look at that. So our answers are the same, except the answer on the left here took us we got to it a lot quicker than the answer on the right. So it's really important that you get the highest perfect square right away here, right away. So it's 64. 16 is not wrong, but it's not the highest perfect square. Okay, let's do a few more examples. Okay, move this one over here a little bit and blow it up. Okay, so I have the 2 times the square root of 192. So step number 1. Well, the 2 is already outside, so we're just gonna keep it as it is here. And the square root of 192, we have to split up. So let me rewrite it here as the square root of okay. So this one, I'm gonna this first one here has to be our highest perfect square, and then the other factor. So what two numbers? One of them, this one here, being the highest perfect square. Okay, so what goes into 192? 64 turns out to be the highest perfect square. So 64 is going to go into here, and then 64 times 3 gives us 192. Okay, so the 2 just keeps dropping down. Now I split those up into, that's 2 times here, 2 times the root of 64. I split these up into 2 separate roots. Okay, so the 2 and then the square root of 64 is 8. So 2 times 8. And then the root 3 is just root 3, because we can't simplify it any further. The final answer is 2 times 8. Comes out to be 16. root 3. Okay. Alright, let's look at E. Okay, now we have a fraction in the front. Don't let that throw you off. Okay, so that stuff's, you know, the 3 over 4 is already outside the house here. So let's move it. Let's just keep it as it is. Okay, it's already good to go here. So we have 3 over 4. There's my radical sign, and now I need two numbers separated by multiplication, and this first one has to be the highest perfect square. I see that 16 times 10 will work because the 16 is the highest perfect square. Now I split those up. 3 over 4 times root of 16 times the root of 10. And I'm going to make my pen a little bit thicker here so it's easier for you guys to see it at home. Okay. Now 3 over 4, again, just drop it down, times the square root of 16 is 4 times the square root of 10. Well, the square root of 10 is just the square root of 10. We can't simplify it any further. Now here I have 3 divided by 4 times 4. Well, I can see that the 4's are going to cancel out here, and I'm just left with 3 root 10. Okay, and if you're not sure why those 4's canceled out, let me do a little side note here in black. Okay, multiplying fractions here. So I have 3 over 4 times 4 over 1. Well, when I multiply those out, I get 12 on top divided by 4 on the bottom, and 12 divided by 3, well, 12 divided by 3 is just 12 divided by 4 equals 3, and that's how we get this 3 over here. Okay, moving on. Okay, now we're dividing the square root of 7 divided by 9, all under one root. So again, the rule says, you know, when you're dividing or multiplying, you can split them up. So this is the same thing as root 7 divided by root 9. Well, root 7 is going to be an irrational number, so we just keep it as root 7. However, the root 9 can be written as a 3. Okay, so there's your answer right there. Okay, we were able to get that 9 out of the root sign. Now you can rewrite this as 1 over 3 times root 7, or I should probably write it as 1 over 3 root 7. That's another way of writing it. Those are all correct answers. Okay, let's move on. Okay, example number 4 here. It says convert the following mixed radicals to entire radicals. Okay, so now we're going the other way. Before we were taking things outside of the roof, outside of the radical sign. Now we're trying to put everything back in and make everything an entire radical. Okay, so the first step here, again, let me zoom in a little bit. Okay, on the 2 root 5. Okay, so now we're trying to get things inside here, so it's under one roof. Well, everything. The 5's already good to go; it's already inside, but the 2 needs to get in there. Okay, so how do I? So I'm just going to write copy down the root 5 because that one is good to go here. Now there's my multiplication sign that's in between here. It's the invisible one. Now how can I rewrite this 2 as a radical? Well, I know that the square root of 4 is the same thing as 2. I'll do a little side thing here. The square root of 4 equals 2. So I can rewrite the 2 as the square root of 4. Hopefully everybody's with me on this one here. If you're not sure, well, we'll get to another example, a little bit of harder example later. Okay, so now we have the square root of 4. They're both under, the radical sign here. So we can combine it because that's using our radical laws under one roof. Okay, so there's my one roof, and there's the 4 times the 5, and finally that just becomes the root of 20. Okay, so here that's our final final answer, we went from root 20, sorry, we went from 2 root 5 all the way to root 20. So this is entire, and the top one is a mixed. Okay, moving on. 4 root 7. Okay, so again, the 7 is good to go. And the 4, well, let me see. What is the equivalent of 4 under the radical sign? In other words, the square root of what gives me 4? Well, the square root of 16 gives me 4. And again, like I said, if you memorize your square roots, your perfect squares, you'll have a lot. You'll have a much easier time, or you know, you'll be able to get your answers a little bit quicker. So do your best to memorize the perfect squares and the perfect cubes. Okay, so 16 goes in here, and then finally 16 times 7. We can combine this under one roof here. So let me just see, 16 times 7. That would be 112, and you're done. That's it. Okay, that's now a mixed radical. Okay, let's just keep rolling here. All right, 10 root 6. Well, the square root of 100 gives me 10. The 6 is already in there, so we'll keep it in there. And then the final answer is root 600. Okay, let's see, 0.4. The square root of 50. Well, this one might be a little bit tricky at first. So let me just write that square root of 50 here. Okay, so how can we make this 0.4 into a perfect into the radical sign? So 0.4. Okay, if you're not sure what number squared gives you 0.4, all you have to do is on your calculator is go 0.4 squared, and that'll give you 0.16. So in other words, you know, doing this a full circle here and then going back here, the square root of 0.16 gives you 0.4. So what we put in here, well, 0.16. Now we write that under one radical sign, and that actually gets to be 8. All right, last one in this section here, negative 5 times 7 here. Well, I'm going to keep the negative on the outside. You know, I don't need to move that negative inside, so I'm going to keep it on the outside. It's going to be a bit of a problem if we move it inside, so I'm going to keep it on the outside. I'm going to write my root sign, and I'm going to write my root 7 here, square root of 7. Okay, well, 5, we know that 5 squared is 25. So 25 is going to go in here, 25. Okay, and then, oh yeah, the final step here, well, the negative stays on the outside. I make one big roof, 25 times 7. Oh, that's just going to be, what is that? 25 times 8 is 200. So 25 times 7 is 175. Okay, let's see what else we have here. Okay, so one of the things this can be useful for is if you want to compare radicals and see which one is bigger, which one is smaller. Changing them to all of them to entire radicals will help you do this. So how do I know if whether root 3 times root 5 or 5 times root 3 is bigger, or root 15 for that matter, or 2 root 8? Which one's bigger? I can't really tell here. I mean, you could if you looked at it and use your estimation skills, but I think putting things under one radical and making them entire radicals will be a lot easier. So 3 root 5, well, that's the same thing as root 9 times root 5, and that's the same thing as root 45. Okay, let's look at the next one. Root 25 times root 3, and that is root 75. Okay, so this one's clearly bigger so far. Okay, root 15 is already an entire radical, so that one is just the same. 2 root 8, well that becomes root 4 times root 8, root 32. Okay, and then finally 8 squared is 64, and that's a 2 there, sorry. And then the final answer there is 64 times 2, which is 128. Okay, so now if we were to arrange these from smallest to biggest, we can clearly see that this is the smallest, then the second smallest, then the third, oops, sorry, lost my pen here. Then the third, there it is, 4, and then the biggest one here is 5. Okay. Okay, let's keep going here, and we'll try a word problem with radicals. Okay, so we have, it says here, example 6, use the Pythagorean theorem, good old Pythagoras, hopefully everybody remembers him, to determine the length, the exact length. Okay, when they say exact, they mean they don't want any decimals, they want either fractions or radicals or something. Okay, they don't want a never-ending decimal. So exact, that should give you a clue that says you know, either a radical sign or a fraction, you know, something like that. Okay, express the answer as A, the exact value in simplest radical form, and then to a decimal to the nearest hundredth. So there we go. So now you get to use your decimal for B here. So let's just find this. This is 1/2, by the way, if it didn't come up properly here. There we go. Okay, so, well, what do we have here? We have, let's label first of all what we're looking for. We're looking for the exact length of AB, which is this length over here, from A to B. Okay. The key thing is that these are right triangles. So there's a right triangle, and then there's a right triangle. So using Pythagoras, and if you remember Pythagoras, is the Pythagorean theorem, I should say, is A squared plus B squared equals C squared. We have, unfortunately here we have, if we just look at this triangle here, if we look at this triangle here, we only have one side, and that's the 6 over here. We need to get this side over here. Let's call this side A, and let's call this side B. Let's call that side B, and then let's call this side over here C. Okay, so we need to get B before we can get C. Luckily we have this other triangle here on the right, and let me redraw this other triangle here to the right. Not the best triangle here, but there's the A up here, there's the C, and there's the D. Those are the vertices. And then this here, this length is 8, and this length is 12. Okay, let me do that a little bit better here. Okay, so let me, there's, there we go, that's more a right triangle. Okay, so now we can use this information, the triangle on the right, to calculate the missing side, and I'm going to put a big X here, X indicating that that's the side we're looking for. The X side, by the way, is the one up here that we'll be looking for, B. Okay, so first we need to use Pythagorean theorem to calculate the side X here. Well, we have, if you notice your A, B, and C here, A, B are the two short sides, and C is the hypotenuse, the long side. In this case, this here would be the C, this here would be the A, and this here would be the B. Now the A and B are interchangeable, but the C is always the long side over here. So let's see. So if 8 over here is A, so then I'm just going to write it as 8 squared plus B squared, and B we don't have. equals c squared, but c is 12. Okay, so let me figure this out now. I have 64. Sorry about that. 64 plus b squared equals 144. I'm not sure what happened to my screen here. Things kind of warped a little bit. Hopefully everybody's still with me. And then I'm going to find out what b squared is by subtracting 64. This is not supposed to be here. 64 away from both sides. That gets rid of that 64, and then we're left with the b squared on the left. And 144 minus 64 is 80. So then finally b equals to, well, how do we get rid of that squared? We just square root both sides. And that cancels out that square there, and b equals the square root of 80. Okay, so now let me redraw the small triangle on the left here, because that kind of got warped out. I have my small triangle on the left, and I already had the side 6, but now I have root 80 here. And I'm looking for AB, and this here again is AB. This side over here, this was A and this was B. Okay, well, the AB in this case is the hypotenuse. It is the long side. So if we were to use our A, B, and C here, this can be the A, this can be the B, and this can be the C. So let's do our Pythagorean theorem again. This time though, I have A squared plus B squared equals C squared, and A in this case is 6 squared plus the root of 80, square root of 80 squared equals C squared. Okay, 6 squared is 36 plus the square root of 80 squared, well, that's just 80, because the square root and the squared cancel out, equals C squared. And I'll keep going down here. I'll use a different color because things are getting a little messy here. 36 plus 80 is 116, equals C squared. And finally, I have to take the root of both sides to get rid of that squared. That'll get rid of that, and that'll leave me with C. And C equals 100, the square root of 116. However, the question says they want a mixed radical. Well, now we do our mixed radical, and I get the square root of 16. I'm going to split that up into two separate roots. And okay, so what the highest perfect square that goes into 116? Let me think about it here. That might be 116 divided by 36. Actually, in this case, we get the square root of 4 and 29. And the square root of 4, even though it seems like a small number, it's actually the highest perfect square, because 29 here is a prime number. So our answer is 2 root 29. And the decimal answer, well, the decimal answer is 10.77032, and so on. You calculate, it runs out of spaces, but you can see how this is not very exact compared to this one. This one is much more exact. Okay, thanks for watching, and see you guys next time.